Hi, Assalamualaikum. My name is Fahad bin Faris Azmi and my matrix number is 01DEE25F1137. So, in this video, we are going to talk about bipolar junction transistor, which in short form is a BJT. So what is a BJT? A BJT is a semiconductor device used in electronics to amplify signal, switch electronic signal on and off. It consists of three extrinsic semiconductor regions, which are emitter, base, and collector. BJT also comes in two basic forms, which is NPN and PNP. So these are the example, the transistor, which we can see the PNP. We have the emitter is on the top, base in the middle, and the collector is under. But for the NPN, is another way around. The collector is on top, the base in the middle, and the emitter is the lower one. These are the bipolar junction transistor significance. So one of them is amplification. It's increasing the strength of small input signal and make it a larger input signal. For example, in microphone. So whenever we talk in the microphone, it's going to transfer to the speaker, which make our voice louder. So second is switching amplification. BJT using transistor as an electronic on-off switch instead of amplifier. For example, is LED control circuit, motor driver, and power control system. For the third is the signal processing. In the BJT, means using the transistor to modify, control, or improve an electrical signal. So in our videos, the objective is to investigate BJT terminal, BJT types, and the material in BJT. So now I'm going to show you how to identify BJT, base, collector, and emitter for NPN and PNP. First, adjust the multimeter in zero adjustment and put it in 10 kilo ohm. So then, the red emitter, the red probe should be put in the base of the transistor, and then the black one should be another one, the terminal. As you can see, the multimeter has gone up, which means the highest resistance is the collector and the lowest resistance is the emitter. Next, the PNP, same as goes, but the different thing is the black probe should put in the base and the red probe should be another terminal. So the exact the same thing, put it in the another terminal, and the highest is the collector and the lowest of the resistance is the emitter. So that you can see. If you can't see, I'm sorry if you can't see it properly. These are the function in BJT. First, the emitter, E for the short form. The emitter injects charge carries into the base. So if you don't understand, carries is the charge particle that move through the semiconductor material to conduct current, which is electron. For the simple word is carries equal to electron. So for the current flow in emitter, which means it provides most of the carries that make up the current. Second, we have the base. The base controls the flow of the current between the emitter and the collector. Current is, it's a very thin lightly dope to allow most carries from the emitter to pass through the collector. The third one is the collector. The collector collects charge carries coming from the E from the emitter through the base. These are the diagram for the NPN current flow. The structure consists of the N-type semiconductor, P-type semiconductor, and another N-type semiconductor. In this type of transistor, a small current flows from the base to the emitter. This small base current allows a larger current to flow the collector to the emitter. Because electrons are the main charge carriers and they move faster. NPN transistors are widely used in many electronic circuits such as amplifier and some switching device. On the other hand, a PNP transistor has a structure made of P-type, N-type, and another P-type semiconductor materials. In this transistor, the current flow in the opposite direction compared to the NPN transistor. A small current leaves the base, allowing a larger current to flow from the emitter to the collector. PNP transistors are also used in electronic circuit, especially in combination with NPN transistor. So now we're going to talk about the bipolar junction transistor material and type. In BJT they have two materials, which is silicon and germanium. So now in silicon, most widely used semiconductor material for BJT in today's world. For reason is the high thermal stability, it can operate a higher temperature. The second is low leakage current, it reduces unwanted current when the transistor is off. And the third is strong and durable, good for a long-term use. So in the silicon, it's only used a 0.7 voltage. As for germanium, it's commonly used in an early transistor before silicon become popular. The reason is it has a low forward voltage because it needs only 0.3 voltage. And second is high electron mobility. It moves faster than silicon. The third is good for sensitive circuit. Germanium are very sensitive to a small signal. But in today's world, silicon replaces germanium because one of the germanium weakness is not stable at higher temperature and high leakage current. The main type of bipolar junction transistor. First, for the NPN, how it works is the base emitter junction is a forward bias. Electrons flow from the emitter into the base. Since the base is very thin, most electrons pass through it without any problems. These electrons are then collected by the collector. The key feature is it uses electron as the main charge carries. Electron moves faster than holes, so the NPN transistor operate faster and more efficiently. This is why NPN transistors are more commonly used in electronic circuit. For the PNP, the base emitter junction is also forward biased, but with the opposite polarity compared to NPN. Holes move from the emitter to the base. Since the base is thin, most holes moves to the collector. The key feature is it uses holes as the main charge carries. Holes move slower than electron, so PNP transistors are slightly slower than NPN. So that's the difference between NPN and PNP.
Now I'm going to show you how to identify NPN using the multimeter. So now take the red probe, put it in the base, and the black one put it in the emitter and the collector. If most of them is a positive, when you put it in the base, which means it's a NPN transistor. Now I'm going to show you how to identify the PNP transistor. Just do the same as the NPN, but the black probe should be put on the base. Then the red probe should be put on the emitter and the collector. If these two have a reading, that means the transistor is a PNP. That's all.
In conclusion, rectifier circuits are a fundamental component in electrical and electronic system. They allow AC power from the main supply to be converted to DC power that can be used by electronic device. Without a rectifier, many common devices such as a mobile phone, chargers, television and computer would not function properly. Therefore, rectifiers are very important in both household and industry application. Thank you.